Howdy there, we're going to talk about five examples about solving radical equations. And a radical is anything with like a square root or a cube root or a fourth root or whatnot. And they're pretty much similar to what we've been talking about through this entire unit. Now, something to keep in mind that a square root is really the inverse of a square. So when we think about the shape, we think, hey, it's only the kind of one side of a parabola turned sideways. And that's something to keep in mind, that we can only have one half because otherwise it wouldn't actually be a function. So we'll deal with that problem when we get there. So the first task is to solve the square root of x plus 5, and that's underneath the square root. And then we take away 1 equals 3. Now, pay attention that, stuff is inside or outside of the radical. That's going to be really, really important as you move forward. So we'll first move the 1 to the right side, so add 1 to both sides, and we're left with the square root of x plus 5 is equal to 4. Now to undo a square root, we'll square it. So we'll raise both sides to the power of 2, and what we do to one side, we got to do the other. So if we raise this to the power of 2, we'll raise this to the power of 2. Now squares and square roots, the square and the square root actually cancel out, and we're left with that x plus 5. And on the right side, 4 squared is 16. So this is a fairly straightforward solution where x equals 11. And we can see that visually, that it's the intersection of the blue curve, 3, and the red curve, which is x, the square root of x plus 5 minus 1. And so when we find x equals 11, we're finding the x coordinate of that intersection point. And that can be a theme here. It's not necessarily exactly what it is, but it is a nice, handy visual representation. All right, so in this one, you're asked to solve and check, because in these types of problems, you might encounter extraneous solutions. And I've put this visual representation to show that our answer is eventually going to be 8. And it is the solution of when the horizontal line 4 intersects with our red curve, the cube root of x plus 2. And notice that the plus 2 is not inside the cube root of x, the cube root, right? It is distinctly outside. So the first thing we're allowed to do, because it's outside, is we can subtract 2 from each side. So we now have the cube root of x is equal to 2. And to undo a cube root, the cube root is the inverse is the cube, so we'll raise both sides to the power of 3. The cube and the cube root, they end up canceling out, and we're left with just x. And, I forgot to do to the other side, dang it. And 2 to the power of 3 is 2 times 2 times 2, so that's 4 times 2, so 8. And that's exactly what we wanted, right? So our intersection point is 8, and how do we check? So our check is going to be really important, and all we do is throw it back into the original equation. So the cube root of my new value, 8, and then all of that plus 2, does that equal 4? That's the real question. Does it equal 4? Well, the cube root of 8, I could use a calculator, or I could know that, hey, 8 breaks down into, I'll do it the longhand way, 2 times 2 times 2, plus 2, and that plus 2 is on the outside. Does that equal 4? And every time I get a pair of 3's in a cube root, right, I need 3 to pull it out, I get 2, and then plus that 2. Does that equal 4? Yes, it does. 4 definitely equals 4. And that's our check. So we've got 2 more, and we want to solve and check for extraneous solutions. Now this example brings up kind of a unique situation, and I'm not showing you the picture on purpose here really quickly, because I want you to see what's about to happen. So I noticed that outside of this, everything is underneath the square root, so there's no plus or minus. I cannot add 2 because it's locked inside of that square root. So I'll have to undo the square root first. So to undo a square root, I need to square things. So the square and the square root, they cancel out, and it's doing it to all of it. So on this left side, we're left with 3x minus 2. And be really, really careful here. It is super tempting, but wrong, to distribute that 2. You cannot distribute an exponent across addition or subtraction. You just can't. So this really means x minus 4 squared means x minus 4 times x minus 4. It's stuff times stuff. It's x minus 4 times x minus 4. So we'll have to eventually distribute that. And in fact, that'll be our next step, is to distribute x minus 4 times x minus 4. So that's x squared minus 4x minus another 4x plus 16. And now we'll solve for x. We're going to go through and we're going to solve for our x values. So we'll add 2. Here, I'll do it in a different color. We're going to add 2. We're going to add 2, and we'll subtract 3x, and we'll subtract 3x, and we'll clean it up really nicely. So this side ends up being 0 because everything cancels out, equals x squared minus 11x, so negative 4 minus 3x, plus 18, and it looks like this is factorable, which is really handy. So 0 equals x minus 9 times x minus 2. And so using the zero product property, we know that x minus 9, if that equals 0, we have a solution. Or if x minus 2 equals 0, we have a solution. So add 9. So x equals 9. That's one potential solution. And plus 2, x equals 2. So now we've got two solutions, and we've got to check them. So let's check when x equals 2. So let's check when x equals 2. Is the square root of 3 times 2 minus 2, is that equal to, we don't know, is that equal to x minus 4, but x is 2, so 2 minus 4. Is that a true statement? Is the square root of 6 minus 2 equal to negative 2? Well, I hope you start to see that we start to run into a problem here, right? The square root of 4 can't equal negative 2 because 2 doesn't equal negative 2. So here we actually have x equals 2 being an extraneous solution. Because when I substitute it back in, it doesn't give me an answer that makes a lot of sense. Here we'll check the x equals 9 and I'll show you that it's possible. X equals 9. So the square root of 3 times x, but x here is 9, minus 2. Does that equal x minus 4? So 9 minus 4. Is that a true statement? So we'll see. That is 27 minus 2. Does that equal 9 minus 4? That's 5. Yeah, that's going to be a lot better. Does the square root of 25 equal 5? Yeah, 5 does equal 5. And so this is our only solution. X equals 9 is our only solution here. And I'll show you what that looks like. Remember, our green curve is our parabola. And remember, it probably will eventually go underneath like that, but it doesn't, because if it goes underneath, it's not actually a function. And so why does this happen? It happens. Why do we get extraneous solutions? It's because, potentially right there would have been our other solution, but that can't be. So our only solution is the one that exists there at when x equals 9. I hope that you see the visual representation why sometimes we get an extraneous solution that won't work. Right, we've got two more problems, and I'm going to do this one. Now this one is a little bit different because instead of a square root, it uses a rational exponent, meaning a fraction exponent. And we'll use that to our advantage here. So in order to undo 5 over 2 as the exponent here, I want to remember one of my properties that a power to a power is really like multiplication. So if I can find something to multiply by that to get to 1, that'll be helpful. So I'm going to strategically multiply by 2/5 to the power of 2/5. I'm not multiplying, I'm raising it to the power of 2/5. And because it's an equation, I have to do it fairly to both sides. So 2/5, or 5, here we go. 5 over 2 to the power of, those two multiply, and they end up canceling most of each other out, right? That's going to be to the power of 1. Everything is really to the power of 1, and so we're left with x squared plus 5x plus 5 is equal to 1, which is really handy. So at this point, we're going to solve this. So minus 1. So x squared plus 5x plus 4 equals 0. We'll go ahead and factor. So x plus 4 and x plus 1 equals 0. So we get two solutions, x equals -4 and x equals -1. And always a best practice is to check. Always a best practice is to check. So here's our check. And I'm going to pause the video just to shorten it up so that you can see the check but not see me have to do it all. So I paused right here as I went through, and we've substituted -4, and I hope that you see that 1 to the 5/2 equals 1. Well, 1 times 1 over 1 raised to the nth power is 1. So this actually equals 1, and that's a check for our x equals -4. I'll pause the video again just to magically appear the second check. I'll move this so that I get a little bit more space. And again, you can see that when I substitute -1 in, that 1 eventually equals 1, and so that's a good sign. All right, in this last one, I want you to try it first. I want you to be really strategic. What are you going to multiply by to get rid of all of the exponents? And, excuse me, we're not multiplying. What are you going to raise both sides to the power to? Whatever you do, you can do it fairly on both sides of the equal sign. You can do it. So I'll let you pause the video here and give it a shot. All right, hopefully you've had a chance to give it a shot. Now, it is more of an advantage to multiply by 2/3 or raise it to the power of 2/3 rather than by 1/3. Just it is to your advantage to do that because the exponents here cancel out, and you're left with x plus 18 is equal to, the 3's also cancel out, x minus 2 quantity squared. So the 2 is left over, so it sticks around as well. And we'll need to do what we did in the previous example where we expand this out. So I'm just going to go ahead and do, so this means x minus 2, so x plus 18 is equal to x squared minus 4x plus 4. Now I did that really quickly. I've been doing this for a while, but you can write it all out. We'll subtract 18, subtract 18, subtract an x, subtract an x. So 0 equals x squared minus 5x minus 14. Go ahead and factor, and we'll get x plus 2 and x minus 7. Give some space. And so x equals -2 is one potential solution, and x equals 7, another potential solution. And the only way we'll know if they're actual solutions is to substitute and check. And I'm going to just show that near the end of this video. So I'm just started the first one. Go ahead and just quickly glance through this. I wanted to pay particular attention to what this means right here, and this is kind of a review. This really means the square root of 16 cubed, and that's how I'm going to solve it to determine that this is actually 64 equals -64, and we see that that is not true. So this is an extraneous solution because they're not equal. I'll show the next one here. And similarly, we can see that 125 equals 125 by substituting 7 into the equation and solving. So x equals 7 is the only solution. This is the only solution to this. I hope this video was informative. The process is similar. Some of them just take a little bit longer to do and kind of applying your previous skills. So thanks for watching, and I'll see you in the next video.